This is the second video for the Quadratics review for Algebra 1. So where we left off was we were factoring number 5b by grouping, and from here I've separated the four terms and I'm looking for the GCF in this first set. So 5 and 1 do not share a factor other than 1, but n squared and n share a 1. Oh. Okay. So 5 divided by 1 is 5, n squared divided by n is n. 1n, we're dividing out the n, so we're left with a 1. And my second set of parentheses, I have 15 and 12, which are both divisible by 3. 15 divided by 3 is 5, and 12 divided by 3 is 4. So we have a problem there. Okay, because this was supposed to be 4 and 15, and I just put a 1 there. Okay, there we go. Now my parentheses match. So n plus 3 is one of my factors, and 5n plus 4 is the other factor. Since we are solving, I need to take both of these factors and set them equal to 0. So n is negative 3. And n is negative 4/5. All right, and we are still factoring and solving. This is fun. All right, next. Let's see, I want the pretty green. Okay, we have a special case here. I know I have a special case because I have two terms. It's called a binomial. And this is called a difference of squares. It's a difference because it has a subtraction sign, and both of my coefficients, and actually my whole term, is a perfect square. So 9x squared is a perfect square, and 1 is a perfect square. But I'm going to factor this the same way we've been doing it, and I just have to insert a 0 in here. 9 times 1 is 9. 9 and 1, 3 and 3. What am I doing? Okay, add and subtract, add and subtract. That's what I was looking for. I'm under the minus column, so that means my signs are different. 9x squared plus 3x minus 1. And I get to grouping. So I have my first set of parentheses, my second set of parentheses, my GCF between 9x squared and 3x is 3x. Factoring out of 3x, I'm left with another 3x because 3x times 3x is 9x squared. And then 3x times 1 is 3x. Both of my terms are negative, so I'm going to factor out a negative. 3 and 1 don't share anything other than 1, so I'm also left with 3x plus 1. So 3x minus 1 and 3x plus 1 are my two factors. Setting those equal to 0 separately. 1 is positive, 1 is negative. I'll add 1 to both sides and divide by 3. So I get one of my solutions to be 1/3. Then I'll subtract 1 from both sides. Divide by 3. My other solution is negative 1/3. Same thing over here with 6b. I'm going to rewrite this as n squared plus 0n minus 25 is equal to 0. 1 times 25 is 25. We know that 25 is 25 times 1 and 5 times 5. But to get 0, I'm going to need 5 and negative 5. Underneath the minus column means my signs are opposite. Factoring by grouping, my GCF here is n. Both of these terms are negative, and they're both divisible by 5. So my two factors are n plus 5 and n minus 5. What am I doing? There we go. So add 5 to both sides. Subtract 5 from both sides. And my solutions are 5 and negative 5. Okay, identify the vertex, axis of symmetry, the roots, solution, zeros, x-intercepts, y-intercept, max and min, and domain and range as well. Okay. Let's make this a little bit smaller so I can see the whole thing. Well, not that small. Not that. Look at all this beautiful work. Okay. No, that's not better at all. Let's do 200. There we go, perfect. Okay. So, the vertex is the point that's either a maximum or a minimum, and it's where our graph changes direction. We're going down, we turn around, we come back up. So that's our vertex. That is 0, negative 9. Axis of symmetry goes straight through the vertex. This is where I could fold my graph in half, and that is the line x equals 0. All vertical lines are x equals, and then the x value that it goes through. The vertex x value should match the axis of symmetry. Okay, the roots, the solutions, the zeros, the x-intercepts are where we cross the x-axis. So that would be at negative 3 and at positive 3. The y-intercept is where we cross the y-axis, and that's here. It just so happens to be the vertex in this specific case, not always. This is the lowest point on the graph, so that will be a minimum. The minimum value is the same as the vertex, so this should match. My domain is always all real numbers from negative infinity to positive infinity. All real numbers can be written with this double vertical line R, or you can write all real numbers. Okay, and our range. We have to go from the lowest to the highest. So the lowest value is negative 9, and the highest value is infinity. So lowest value is negative 9, and we're going up from there because y is greater than or equal to negative 9. It can also be written like that, from negative 9 to infinity. All right, over here. This is my vertex, 3, negative 9. The axis of symmetry goes straight through the vertex. That's where we could fold our graph and have the same thing on both sides. That goes through the x value of 3, and this should always match. My solutions, my roots, one of them's at the origin, and one of them is at 6. The y-intercept just so happens to be the origin this time. This again is a minimum, and the minimum value is the lowest number, that's negative 9. So again, this matches with that. My domain, again, always all real numbers, goes all the way to the left and keeps getting wider and wider, all the way to the right and keeps getting wider and wider. My range is from the lowest number to the highest number, so I actually have the same thing again, negative 9 to infinity. So y is greater than or equal to negative 9, or I can say negative 9 is less than or equal to y is less than infinity. Okay, I am multiplying here. I know I'm multiplying because there's no plus or minus in between the parentheses. I have a binomial times a trinomial. So I'm going to set up a box, but I'm actually going to have 6 boxes. So this is 4a plus 2, and this will be 6a squared minus a plus 2. So 4 times 6 is 24. This is really a to the first. That's just an a. Sorry, that kind of looked like a 9, and then I was confused. was like, is that a 9? No, nope, it's a minus a. Okay, so 4a times negative a is negative 4a squared. 4a times 2 is 8a. 2 times 6a squared is 12a squared. 2 times negative a is negative 2a, and 2 times 2 is 4. Now we look for our like terms. So this is a squared and that's a squared. And this is just a and that's just a. So my final answer is 24a cubed. 12 minus 4 is 8. Negative 2 plus 8 is 6. And there's my polynomial. Okay, I'm going to do the same thing over here. 7k minus 3, and then k squared minus 2k plus 7. 7k times k squared is 7k cubed. 7k times negative 2k is negative 14k squared. 7k times 7 is 49k. Negative 3 times k squared is negative 3k squared. Negative 3 times negative 2k is 6k. And negative 3 times positive 7 is negative 21. Okay, looking for like terms again. We have our squared terms. We have just our k's. So my final answer is 7k cubed. These are both negative. These are both positive. All right. And that's it.